So, one of the interesting things about probability, we have to know that it started from a pack of cards only. People wanted to find out the chances of their winning um, in gambling. So that's how it started. So a pack of cards consists of 52 cards in four suits, which 13 cards each. The four suits are, of course, spades, clubs, hearts, and diamonds. Now, out of these, spades, clubs are black faced cards. Spades and clubs are black faced cards. Hearts and diamonds are red faced cards. So the ace, kings, queens, jacks, or knaves are called as honor cards, and king, queen, jack are called as face cards. Ace is not king, queen, and jack or knives called as face cards. So in our problems, this is what we have to uh, be thoughtful of. And then you have A, K, J, K, J, Q, and then you have two, three, four, five, six, seven, eight, nine. So one, two, three, four, five. No, 2 to 9 are 8, 9, 10, 11, 12, and one more. Uh, one more.
Sir, 10, sir.
So these are the 13 cards. So now, based on this, we have question. So let us look at the question. One card is drawn from a well shuffled pack of 52 cards. Each outcome is equally likely. So calculate the probability calculate the probability mm, that the card will be A with a diamond, B uh, not an ace, C a black card, D uh, not a diamond, then E mm, okay a black a diamond a heart. a prime number. So let's look at the solution. Now, what is, first of all, the sample space is 52. Okay. The n of s is 52. There are 52 outcomes of selecting one card out of 52. The one card is drawn from a well shuffled pack of 52 cards, so n of s is 52. Okay. Next, now the first one. Now E1 is the event that the card is a diamond. So this is one suit out of 4. So what will be n of E?
13, sir.
So there will be 13 cards of diamond suit. So therefore, probability of E1 is n of E1 by n of S. That is 13 upon 52, which is 1 upon 4. Okay. Next. Clear?
Yes, sir. Clear, sir.
Next. E2 is the event of not an ace. Okay. Let's say right E2 is event of getting an ace. So ace has 4 denominations, right?
Yes, sir.
4 suits. Ace of hearts, ace of diamonds, ace of clubs, ace of spades. So n of E2 is 4. Okay. Now, probability of E2 is 4 upon 52, which is 1 on 13. But we want E2 bar, event of not getting an ace. So this will be from our previous discussion.
1 minus probability of E2.
Yes. So this will be 1 minus 1 upon 30, which is 12 on 30. So that is what is a required statement. Next, it is a black card. Let E3 be the event of getting a black card. What will that be? N of E?
28 cards, sir.
26 cards.
Sorry, 26 cards.
26, because 13 and 13. So spades and clubs, both are black. So we get just a second. So we get 26. So P of E3 is N of E3 by N of S, which is 26 upon 52, 1 upon 2. Exactly half. Of course, these things with practice you can directly write it. Then last one, not fourth one, not a diamond. Not
3 by 4.
correct. n of E2, E4 is 13. E4 is event of getting a diamond.
Sir, E4 is not getting a diamond.
No, I put 13, right? There are 13 diamonds.
Okay. Yes, sir, got it.
So P of E4 is, of course, you can write not getting a diamond directly. You get 13 on 52, which is 1 by 4. So probability of not getting a diamond is 1 upon P of E4. Sorry, 1 upon 1 by 4, which is 3 upon 4. Okay. So that's the answer. Next, E5 is the event of getting a prime number. So, and sorry, E5 will have 2 of hearts,
2, 3, 5, and 7. Times 4.
time 4 times, and 4 suits. Okay. So 4 into 4, 16. Therefore,
16.
probability of E5.
4 by 13.
Yes. Oh my God. So this is how we do that. So now I'll do some problems which are out of the book. A convex hexagon in 6 sides. In a convex hexagon, 2 diagonals are drawn at random. The probability that the diagonal intersect at an interior point of the hexagon. So this is the hexagon. Now, first of all, we have to identify total number of diagonals of a hexagon. From the total number of diagonals, we have to select any two. Say, number of diagonals in a hexagon. There are 6 points, 6 vertices. Take any two and join them, you will get a line. However, so this will be 6C2 minus 6 sides, because If the 2 points chosen are the adjacent points, adjacent vertices, they'll form a side of the hexagon, they'll not form a diagonal.
Yes, sir.
Okay. So, so 6C2 minus 6 will be the number of diagonals. 6C2 is 6 into 5 by 1 into 2, 15. 15 minus 6 is 9. So there are 9 diagonals. So you can see that 1, 2, 3. Now this one, from the second vertex, 4, 5, 6. From the third vertex, 7, 8, and then this is the ninth. Now, the diagonals either intersect on the vertex or they will intersect um, on, inside. There are only two possibilities. Okay, there are only two possible. Now we have to select two diagonals in a convex hexagon. Two diagonals are drawn at random. So out of the 9, any two you will draw. In how many ways can you draw? The number of ways of drawing any two diagonals. The number of ways of drawing any two diagonals. What are the number of ways of drawing any two diagonals?
9C2, sir.
9C2. 9 into 8 by 1 into 2. 9 4s 36. This is our n of s. N of s is 36. Number of ways of drawing any two diagonals of s is 36. Okay. Next. Now the number of ways in which we select two diagonals which will intersect at which will intersect inside. So what we should not select is from these two yellows. Okay, we should not select these two yellows. Just I'll put this as green so that it will be clear. Now we should not select these two yellows or these three reds or these three. So yellow is repeating here. So or these three or these three or these three. So any two of these you should not select. So there will be repetitions. So at any given vertex, there are 6 vertices. So the number of ways of selecting the diagonals that will intersect on the vertex. Okay, let E be the event of selecting two diagonals that will intersect at a vertex. Now, what will be n of E? There are 6 vertices, and at each of these 6, there are 3 diagonals. So you will get 18. Now, n of E will not be 18. Of this, there will be some repetitions. So tell me how many will be repetitions? See, if at this point I select 2 yellows, that is one. There 3C 2 ways, that is 3 ways. I can omit this or this or this, and then I'll get 2 diagonals. Okay. Now, so then I have 3C2 here. These red, these are distinct. Now here I have a yellow. So suppose I choose this yellow.
Sir, I actually did this before. In the way I did it,
Yeah,
the logic was that the intersection of the diagonals will be inside the hexagon only if 4 unique points are taken to draw the diagonals.
okay, so
that can be done in
4 distinct points.
Yes, 4 distinct points, and that can be done in 6 C4 ways.
Okay, okay, if all right. Meaning if okay, I got your logic. What you're saying is, if there are 3 distinct points, 1, 2, and 3, then definitely the diagonals that you choose is okay. So that means you have to select 4.
Yes, sir. 4 distinct points from 6 points.
Then 6C4. Then
6C4.
but then of that 4, they can be adjacent. How will you remove the adjacent points? Now of this 4, 6C4, then you have to select any 2. All right. You cannot select things that are just see 1, 2, 3, 4. The adjacent points again cannot come.
No, like sir, the adjacent pair can be cancelled. So there are 2 ways of drawing diagonals with 4 points, right, sir?
No, there may be many ways. Suppose you see this 1, 2, 3. 1 will definitely be adjacent. So 1, 2, 3. No, 1 will be okay. So suppose you take the case 1, 2, 3, 4.
Yes, sir.
This case you have to subtract 3 if they are adjacent. Now, if they are 1, 2, 3, and 4, then you will have to subtract 2.
No, like if you choose any 4 points, there will always be one way of drawing the diagonal such that it intersects in the middle.
Okay, let us see your logic. Suppose I choose 4 points, 1, 2, 3, 4. Okay. Hmm. Now this diagonal and this diagonal do not intersect. It is not that any two diagonals intersect also. There are diagonals that do not intersect.
Yes, sir, but we're not counting them now, sir. We're just selecting 4 points, any distinct 4 points. You're not checking if the
So
diagonal
here, here,
one.
here there is only one way.
Yes,
Here.
sir. So in any 4 points you take, there will be only one way in which the diagonals will intersect.
Let us check that. Suppose I do this. Hmm. Now I choose, let's say, for all adjacent. Okay. First case was 2 in pairs adjacent. Now all 4. So now in this, uh, yeah, the only one way we can draw a diagonal that will intersect is this.
Yes, sir.
All right. And next, suppose we have okay. Yeah. So here only possible way is these two and these two. So when we select 4, there's only one way in which they intersect. Yeah, this way. This. So then, so select any 4 vertices to get one way. Hmm. So from 6 you select 4, so you get 15. 6C4 is 15. 6C4 is same as 6C2, so it is 15. So P of E is N of E by N of S, 15 by 36. Maybe we are missing out on one answer. Let me check. 3 correct. 3 5s 15, 3 12s 36. Answer is right. 5 upon 12 is the answer. Now, next one. So, two small squares on a chessboard are chosen at random. Probability that they have a common side. Now, this is a permutation. Basically, it's a permutation combination question. What is N of S?
Sir, 64.
N of S is 64C2.
Sir, but there's 64 squares, right, sir?
Yes, there are 64 squares, of which
Okay, we have to pick 2 at random. Got it, sir.
you have to pick 2 at random.
Yes, sir. Got it, sir.
Now we have okay, difficult to draw perfectly, but I'll try. So now when will you get um, if you do for one side, you will be able to do for the other side. Okay. Now to get squares that are adjacent to each other, then how will you do? Any two adjacent. We did this and we did this in permutation combination. Number of ways of selecting squares that have adjacent sides. You want to try?
So do we have to split this into smaller events?
Not necessary.
Like first squares that have two sides like that have a two squares next to it and then four squares next to it or three squares next to it like that.
Hmm. Okay, you can count this way. Okay, you can count this way. You just see here in this particular row. If I want to select adjacent, you say horizontally adjacent. Okay, this is vertical and horizontal. First, we'll go by horizontal. So you have pairs. How many pairs of adjacent pairs? One, two, three, uh, four, five, six, seven. Seven adjacent pairs. So here you get 7C1. From the seven pairs, you get the any one as adjacent. Similarly, for the second row, you again get 7C1. All right, seven pairs. One, two, then third, fourth, that is third pair, fourth, fifth, fifth, sixth, sixth, seventh, seventh, eighth. So you get 7C1 seven times. whatever. So you get 7C1 7 times. 7C1 8 times actually. Now look at the vertical squares. You again get 7C1, 7C1, 7C1. Vertically adjacent. So this covers all the adjacent. Did you get? So I get 7C1 into 8 into 2. Alright. Basically it is 7C1 into 16. So
Yes, sir.
N of E. So the probability of E will be N of E upon N of S, which is 7 into 8 into 2 upon 64C2. 64 into 63 by 1 into 2, that is 1 into 2. So 7 cancels 63 9 times. And then 8 to 16, 16 to 32. So 32, 8 4 32 cancels 64 2 times. So we are left with 1 upon 2 into 9, that is 1 upon 18. One upon 18. So this is the answer. Two small squares on a chessboard. So 1 upon 18. So did you get how to do?
Yes, sir. Understood, sir.
Okay, then the typical problems of balls. Here it appears as there are multiple events, but they are single event problems only. These are 7 white balls and 3 black balls are placed in a row at random. The probability is that no two black balls are adjacent. First, identify N of S, total number of possibilities of arranging 7 white and 3 black balls. Assume all the balls different. Yes. What is N of S?
I don't know, sir.
This is a permutation problem. N of S is 7 plus
So
3
7
plus
okay,
3, 10
10
factorial.
factorial by okay, yes, sir. Got it, sir.
The number of ways of arranging, number of ways of arranging 10 things in which 7 are alike of one kind, 3 are alike of another kind. Okay, this is N of S. Now, probability that no two black balls are adjacent. So what do? You first place the white balls. These are all white balls. Now you have to insert the black balls, but you have how many spaces?
8 spaces.
8 spaces. So how will you arrange the 8 black balls?
8 C3 ways
Into 3 factorial.
into 3. Yes, sir.
So N of E is, first of all, these white will arrange amongst themselves in 7 factorials. Then there are 8 spaces, and which 3 can be arranged in 8p3 ways or 8c3 into 3 factorial ways, which is said 8p3 ways. Okay?
Can you explain this again, sir? How did we get 8p3 into 7 factorial?
8c3 into 3 factorial. 8c3 is of these 8,
Yes, sir.
we'll select
Correct,
three
sir.
positions where we'll insert
Yes,
the
sir. And that can, yes, sir, that
this
I
can be
understand.
arranged in 3 factorial ways. So this is 8p3.
Okay. Yes, sir, got it, sir.
Yeah. NPR is NCR into R factorial.
Yes, sir.
Okay. So 8p3. Now the whites can arrange amongst themselves in 7 factorial ways.
Okay, that is how we got the 7 factorial. Yes, sir.
Yes. Yes. Whites, no? This was on blacks. And this was on white balls. Okay. Got it? This was so many problems we did, seating
Yes, sir.
problems and permutations. Exactly that. The problem with maths is we lose a little touch. We go into one topic, previous topic concepts now, they fade. That's why we need repeated practice. So N of E is 7 factorial to 8p3 ways, whereas 8 into 8 factorial by 5 factorial. So 8 into 7 into 6 divided by now 10 factorial into 7 factorial into 3 factorial. Let us see. Now this doesn't exceed. No, let us do this. 10 factorial by 7 factorial, 3 factorial is 10 into 9 into 8 upon 1 into 2 into 3. The same as 10c3 basically. Okay. So you get 3 3s 9, 2 4s 8, so 120 ways. Now this N of E oh no, there are 7 distinct balls, so it is not, it is totally 10 factorial. I'm sorry. These are, take this as 7 distinct white balls, 7 distinct black balls. So you will not get this. If we take alike, then we don't have to do the 7 factorial. If they are alike of one kind, it will be 7 factorial by 7 factorial. Okay. You take this as distinct. Just like 10 men and 3 women,
Yes, sir. Got it, sir.
if they are arranged in a row and how many ways they can be done, they'll be done in 10 factorial ways. After that, the categories will see. So this is not okay. So 8p3, 7 into 8p3 into 10 factorial. So we get 8 into 7 into 6 by 10 into 9 into 8 into 7 factorial. So we have 8 gone. Then we have 2, 3, 2, 6, 3, 3, 9. So 14 upon 30. The 2 5s 10. So you will get 7 upon 15. Yeah, we get 7 upon 15. That's the answer. Answer is present. 7 upon 15. Got it?
Yes, sir.
All right. Last problem for today. An elevator starts with M passengers and stops at N floors, where N is greater than M. So probability that no two passengers alight at the same floor. How would we do? How would we do this?
Sir, the number of ways in which n passengers can get align at n number of floors is okay. I don't know how to put it in a sentence.
Hmm. No,
Is basically n power m.
correct. Because the first passenger can alight at any one of the N floors. The
Yes, sir.
second can also alight at any one of the, just a second, just a second. The second passenger, N floors, third N floors, like that, M types. So you have N power M. Okay. Now, no to E is the event that no two passengers alight at the same floor. That means what? From the N floors, there are N floors. See, from n floors, select m floors. All right. And then you get n cm. Now place the passengers in these m floors, and now they can be into
into
m
m
factor.
factorial.
Very good.
Yes,
So
sir.
this is
N
n.
npm.
Good. N of e is np.
So probability is npm by n power m.
Yes. So p of e is npm by n power n. That's a probability. Okay. All right.
Yes, sir.
All right. I'll stop here today. Tomorrow I'll start with addition theorem. Okay. These were
Yes, sir.
on simple basic property, basic probability. There are varieties of questions. These ones. Okay. Out of the box, meaning out of the book type of questions. Okay. Based on geometry, based on logic, and so on. We will do something more based on theorems of addition theorem of probability. Tomorrow's class. Tomorrow we'll meet at 11.
11 o'clock, sir. No issues, sir.
Okay.
Yes, sir. Thank you, sir.